The depth of water in a harbour is 20 metres at high tide and 12 metres at low tide, which occurs 6 hours later. The graph shows how depth changes over the 24-hour period. So here it is high tide, here it's at low tide. Find the equation of the water in metre in terms of time in hours in the form ht is equal to a cos bt plus c. A ship can enter the harbour when the depth of water is 15 metres or more. Find the times in a 24-hour period the ship can enter the harbour. Give your answer in hours, minutes, correct to the nearest minute. Okay, so here we have the graph. So we've got h of t is a cos bt plus c. Let's mark on the high tides and low tides. So 0:20, 6 hours later, 6:06:00, 12 up to 12 o'clock is high tide. At 6 o'clock in the evening, 1800 hours, it is low tide, and then at 12 midnight, it is high tide. Alright, the A stands for the amplitude of the graph. Now the amplitude can be found by taking the highest value, which is 20, the high tide value, minus the low tide value, which is 12, and then divide by 2, and we get that the amplitude is 4. So A is 4. C is the next easiest thing to do. If you draw this thing in here, the axis has been shifted up 16 units. So C is what's known as the vertical translation of the graph, original graph of h of t is cos of t. So C is equal to 16 because it's gone up 16 units. The period is found from doing 2 pi over b. Now the period of this graph, this graph repeats itself after every 12 hours. So the period is equal to 12. So we put 12 is equal to 2 pi divided by b. Rearranging that, we get b is 2 pi over 12, which is pi over 6. So my graph is h of t, a cos bt plus c. A is 4, c is 16, and b is pi over 6. So my equation will be h of t is equal to h of t is equal to 4 cos pi by 6 pi divided by 6t plus 16. Right, the ship can enter the harbour when if h of t is greater than 15. So here is my graph. Here's the graph of h of t. So what I need to find is the intersection of h of t is equal to 15 with this graph here. To do that, I need to use my GDC. So it can enter the harbour here. Can't enter in this time period, but can enter the harbour here and can enter the harbour here. So using the GDC, so I need to go to a graphing mode, which is this one here. First I'm going to set up my axis. So menu, window zoom, window settings. So my minimum I want to be, let's put just -1 and make this 25. A bit more than I actually need. Make this one at -2 and make my maximum at 22. And then enter in my graph. So my graph is going to be 4 trig cos, now I need to put another set of brackets in, of pi divided by 6 times x plus 16. That gives me the graph that I want. I'll just move the label down a bit. And then Command G, put in h of t is equal to 15. And then I need to find the point of intersection of these two graphs. So to do that, I need to go to Menu, Analyze the graph, Intersection, and then I need to do this, repeat this. There's one time there. Just move the labels along a little bit. Menu, Analyze the graph, Intersection. Sorry, let's press Escape. And to the left, to the left, to to the right. There's another one. Menu, analyze the graph, intersection, to the left, to the right, and menu, analyze the graph, intersection, to the left and to the right. There we have them. Going back, there's a screenshot. So the first one is at 3.483. Next one is at 8.517. The next one will be at 15.483 as well. So it says 48. This has been rounded off, so this is a bit more accurate. We can use that decimal. And the last one will be at 20.517. So we need to write down the ranges that the ship can enter the harbour. I want it in hours and minutes, so I need to change that into minutes. So 0.483 hours is 0.483 times 60 minutes. To the nearest minute, that will be 29 minutes. Same for this one here. So that will be 0.517 hours, 0.517 times 60, which gives me 31 minutes. So the ship can enter the harbour between 0 and 03:29, and then it can enter again at 8:31 to 15:29, and then finally it can enter from 20:31 to midnight, if we're just considering the 24-hour period. So this has been a graph to show you how to model cosine graph to a tide problem and then use it to answer a problem.